Right in front of me here is a VZ600i. It's our latest terrestrial laser scanner. It's quiet, it's fast, it's lightweight. We have a GNSS receiver, completely touchscreen user interface, and 2 slots for batteries. The laser pulse rate is at 2.2 megahertz, but more importantly, the line speed is 410 lines per second, which is very important to measure speed. And in the back, completely touchscreen interface with one-touch button operation. New to the terrestrial laser scanner are internal cameras. In the past, historically, we've always integrated external camera, but for the new generation, we have 3 internal cameras to accommodate the 105 degrees vertical view. One unique attribute on the scanner is that not only that it takes laser data within 25 seconds at 6mm resolution, but it also captures images at the same time, which is a very unique engineering perspective for RIEGL terrestrial laser scanner. And you can enter in your parameter and it will calculate the amount of time that you'll have to spend on that scan position. Over 1,200 scan position, 1 minute and 22 seconds per scan position. Now I challenge you to beat that. Onboard face detection, all the images of human faces are completely blurred out, and this option can be turned on or off up to the customer discretion. All these laser scanners on the market, and they all produce a very beautiful point cloud, but you really have to look at productivity. The data is completely synchronized to the CF Express card, so all you do is just pull the card out, put it into the software, and my colleague was able to turn a registered point cloud, filtered, colorize the data, and then also export the data within 25 minutes. In the past 15 years that I've been with RIEGL, I've seen the usage and I've seen the productivity of these systems as it gets developed. And now till this very moment, the 600i is by far the most productive system on the market. Right in front of me here is a VZ600i. It's our latest and greatest terrestrial laser scanner. Started back in 1998 with the first development of our first terrestrial laser scanner. Now the first generation has proven to be a very exciting system for the TLS market. Visually, starting from the top down, we have a GNSS receiver, completely touchscreen user interface, and also 2 slots for batteries. Okay. With the batteries, it uses only 1 cell at a time. So the user can hot swap as it scans throughout the project. We provide 2, 4, 6, it doesn't matter. It's a very high speed scanner. Just to give you some quick specs on it. It scans the laser pulse rate is at 2.2 megahertz. And but more importantly, the line speed is 410 lines per second, which is very important to measure speed, because if you have a scanner that pulses at 10 megahertz per second, and if your mirror cannot catch up to it, points are not very effective. New to the terrestrial laser scanner from RIEGL are internal cameras, right? So in the past, historically, we've always integrated external camera, but for the new generation, we have 3 internal cameras to accommodate the 105 degrees vertical view. Although the system has been introduced last year, but we're always constantly developing new components for the scanner, right? So it's just as external camera options, but also new interface options, such as face detection for scanning an environment where there's a lot of people. Also measuring productivity. So all these laser scanners on the market is very, very, very nice, and they all produce a very beautiful point cloud. But one thing we've been trying to emphasize and develop for the new VZ600i is productivity. You really have to look at productivity and measure productivity, and it really starts with the laser scanner, but it doesn't end there. It ends on the back end with a deliverable, perfectly georeferenced registered point cloud. And I also want to show you that on Monday, we came here and scanned immediately. And I want to give you some information on that too as well. And we brought the data into a third-party software for viewing, such as Unreal Engine. And then a quick live scan demo on the VZ400i. So let's go ahead and get started. Here are some key components that you will find on the VZ600i. As I already listed, you have the laser beam in the front, also 3 internal cameras, and in the back, completely touchscreen interface with one-touch button operation, and also a quick release mount, which allows you to put the scanner directly onto the floor and scan at the same time. Here are some highlights that I want to point out with the 600i. When I say ultimate speed, right, so we measure these speeds by the amount of coverage and also the amount of scan positions we can do in 1 hour, 1 minute, or 1 day. So we've been bench testing this system. I myself have over the past summer, which I'll show you some real world numbers shortly here at the end of my presentation. One unique attribute on the scanner is that not only that it takes laser data within 25 seconds at 6mm resolution, but it also captures images at the same time too as well, which is a very unique engineering perspective for RIEGL terrestrial laser scanner. Look at the performance, right? So a 25-second scan will deliver 6mm resolution at 10 meters range. Now, our system is always notoriously to be user-defined. So working on a time-of-flight technology to get a higher resolution, the only thing it's going to cost you is more time. And you can enter in your parameter, and it will calculate the amount of time that you'll have to spend on that scan position. So for example, if I were to lower the resolution to 5mm at 10mm range, it'll be a 35-second scan. So it's all user-defined, but we find the sweet spot for productivity to be 6mm resolution at 10-meter range. And then some new integrated development. So here you can see we have an internal camera option, which is standard, and it captures images at the same time. But we've recently also introduced a 360-degree sphere camera, a Theta model, which is their flagship model this is good for indoor scanning, where it just captures one images and then takes a scan 360 degrees. But for historic scans of old buildings or an old site, we have a high resolution camera, think up to 32 megapixels, Sony Alpha 7R4. So these are all options that we offer to our customers for external imaging. Moving on, move to onboard face detection. So when a scanner takes the images, all the images of human faces are completely blurred out, and this option can be turned on or off up to the customer discretion. Not only it detects people, but it also detects statues too as well. So if you want to hide the face of a statue, you certainly could do that. Okay, let's get some real world number on productivity, right? I've always emphasized on productivity. Over the summer, I've done a lot of projects, and these projects consist of urban, transportation, and indoor. I particularly like the transportation because this project, all of my transportation is focused on linear projects, right? So in the past 15 years that I've been with RIEGL, I've seen the usage and I've seen the productivity of these systems as it gets developed. And now till this very moment, the 600i is by far, in my opinion, and tested, the most productive system on the market. And you'll see that with these real world numbers. Yeah. So in an urban environment, we scan up to 466 scan position, cost me 520 minutes. Then we got 743 scan position, which covered 3.5 kilometers in 390 minutes. And then the last one, indoor, of course, we move indoor and outdoor, it doesn't matter. 502 scan position, which cost me 588 minutes. So what does that mean? If you look at it, over 1,200 scan position, these are all different projects that I've done. Some projects are controlled with surveyor points on the ground, particularly the linear project. So that's all accounted for, right? Because when you sample a target, it does take a little bit more time. But nevertheless, over 1,200 scan position in 1,478 minutes equals out to 1 minute and 22 scan position, 1 minute and 22 seconds per scan position. So by the time I pick it up, move it to the next position, press the button start, it's 1 minute and 22 seconds. Now I challenge you to beat that with the RIEGL system. So here's the project that we did on Monday. We started scanning at 6:30 and we finished around 7:10 or so. This was people coming up and talking to me. So we did 45 minutes of acquisition time, and everything is time-stamped, right? So from your first scan position to your last scan position, everything is completely time-stamped. But nevertheless, we moved from all the way around the parameter and also inside. You can see the top left corner of the screen. That's the inside of this auditorium. Right here. And the data is completely synchronized to the CF Express card. So all you do is just pull the card out, put it into the software, and my colleague was able to turn a register point cloud, filtered moving objects, colorize the data, and then also export the data within our one-touch processing wizard within 25 minutes. So, and this data is available too if you choose, if you want it. Here's a quick video of a fly-through that's also generated in our software as well. Could be a little lag because of the Wi-Fi. So what you can see here is that the dynamic ranging of the scanner, based on the pulse repetition rate, at the rate that I selected, which is the max rate, 2.2 megahertz, it scans up to 250 meters range, right? So we can scan 1 foot or 500 foot, and the accuracy is rather dynamic, not so much linear. Okay, thank you for your attention, but before we leave, let's go ahead and take a quick scan. This is already set up to go. All I do is just press the button start. It's quiet, it's fast, it's lightweight, 13 pounds. And for indoor situation where your GPS denied, the IMU takes over for tracking, right? So how are we successful with registration? Through 4 unique attributes. So we know where we're at with GPS. We have a digital compass that gives us a heading, and we have a 3-axis inclination sensor that levels it, and also an IMU2 as well to track its position indoor when your GPS denied. And that's it. Thank you very much for your attention.